All right, so our first question is number 3, part B. So they've given us right here the length of one side. And this other measurement that they've given us, this line segment goes from the center to a side. They don't show it, but it is making a right angle with that side. So this 12.1 inches right here is the apothem. So to find the area of this figure, 1/2 apothem times perimeter. We were asked to find the perimeter anyway. For the perimeter, we need the number of sides times the length of one side. How many sides do we have? How many? No, there's more than 6 sides. 8 sides. How big is each side? 10 inches. So 8 times 10 gives me 80. So our perimeter is 80 inches. That's the first thing I needed to find. Then for my area, like I said up above, that's 1/2 apothem times perimeter. The apothem was given to us in the picture as 12.1 inches. And then our perimeter is 80 inches. So 1/2 times 12.1 times 80 comes out to be 484. And since we're finding area, that would be inches squared. To do part A, you would follow the exact same process. On part A, they've given you the length of one side and they've given you the apothem. So you would calculate the area for part A in exactly the same way, just with different numbers. Yes, Deborah. Number 1, part B? Absolutely. So what kind of a shape do we have here in number 1, part B? This is a rhombus. I know it's a rhombus because both of these diagonals are being bisected. These two sides are congruent, and these two pieces are congruent. A rhombus, both of my diagonals are bisected. If it was a kite, only one of my diagonals would be bisected. But even if it was a kite, I'm going to use the exact same formula because we have a formula for a rhombus or a kite. The area formula for the rhombus or a kite is 1/2 diagonal 1 times diagonal 2. So I need to find the lengths of both of my diagonals. In the picture, it tells me that this much right here is 24 inches. So how big is this? 24 inches. We're going to go ahead and call this diagonal 1. Diagonal 1, the whole thing, from corner to corner, I have 2 segments that are each 24 inches long. So diagonal 1 would be 48 inches. So I can go ahead and sub that into my formula. Area is 1/2 times 48. And then we have diagonal 2. I know this bit right here is 36 inches. So how big is this bit? Also 36 inches. So diagonal 2, I have 2 segments that are both 36 inches. 2 times 36 comes out to be 72. So diagonal 2 is 72 inches. So 1/2 times 48 times 72 gives me an area of 1,728 inches squared, because I had inches times inches. Area is always squared units. What else would you guys like to see? Yes. 2C? Oh, 6, yes. Number 6. Number 6 says, if the area of a parallelogram is 605 miles and the height is 5 times the length of the base, what are the lengths of the base and the height? So you guys have to know the area formula for a parallelogram. This is one of the ones that you have to memorize. Area is equal to base times height for a parallelogram. They tell us that the area of this parallelogram is 605 miles. So that's what we're going to put in the place of the A, 605. It says the height is 5 times the length of the base. I have no idea how big the base is. If I knew that the base was 7, the height would be 5 times that, or 35. If the base is 10, the height is 5 times that, or 50. But I don't know how big the base is. So what can I call it since I don't know how big it is? X. So my base is X. And if I'm calling the base X, and I know the height is 5 times that, what could we call the height then? 5x. So this is what I'm going to put in for the base and the height into that equation where I already have the 605 substituted in. So x times 5x. What is x times x? X squared. So this would be 605 equals x times 5x would be 5x squared. I need to get rid of this 5 out in front. What operation is connecting the 5 to the x squared? Multiplication is connecting those. And so what do I use to undo it? Division. We're going to divide both sides by 5. And 605 divided by 5 is 121. So I have 121 equals x squared. What do I need to do now? Square root. If you do it to one side, you do it to the other side. We're square rooting to get rid of this squared on the x. What is the square root of 121? 11. 11 equals x. And what were we letting x represent here? The base, b. So x is 11. What kind of units should we put with that? Miles. The height is 5 times that. What is 5 times 11? 55. So my height is 55 miles. Give me just a moment and I'll add my units on there. There we go. Nicely done. What else would you guys like to see? Number 2, absolutely. A trapezoid has one base of 15 inches, a height of 14 inches, and an area of 182 square inches. Now you do need to know the area formula for a trapezoid for the test tomorrow. Area formula for a trapezoid reminds me a lot of the area formula for a triangle. Remember, triangle is 1/2 base times height. Only a trapezoid has how many bases? 2 bases. So 1/2, we only have 1 height. We have 2 bases that we have to add together. So 1/2 times the height times base 1 plus base 2. We're going to take the information that they gave us and substitute it in. They said the area is 182 square inches, so I put that in the place of A. So 182 equals 1/2. And then we have a height of what? Height of 14. And one of the bases is 15. I don't know how big the other base is, so I'm just going to leave that as base 2. You could put 15 in for base 2, and then we'd find base 1. It doesn't matter which one we find. We're just needing to find the other base. And now we're going to solve this. First thing I want to do is get rid of this fraction, this 1/2. What operation gets rid of fractions for me? Multiplication. What do we multiply by to get rid of a 1/2? 2. So we multiply both sides by 2. 2 times 182 is 364. So I have 364 is equal to 14 times 15 plus base 2. What operation is happening here in between my two sets of parentheses? Multiplication. So I've got a choice here. You can distribute that 14 to both pieces. You can solve it that way. It's mathematically valid. It'll give you the right answer. It's going to take one extra step. Then if you decide to divide to get rid of that multiplication, we can divide both sides by 14 to get rid of it over here. Again, you can distribute or you can divide by that 14 here. 364 divided by 14 is 26. So 26 equals 15 plus base 2. I don't need the parentheses around that anymore because there's nothing else on that side of the equation. To get base 2 isolated, now I just need to subtract 15 from both sides. What is 26 minus 15? 11. What kind of units should we put with that 11? Inches. So 11 inches is equal to base 2. Or you could have called it base 1. Again, it does not matter as long as you're looking for one of those two bases. Yes, what else would you like to see? Which one? D? 14D, absolutely. So very back page, 14D. For 14 part D, we have several different shapes that have been put together. One of them I kind of see right here. What shape is this? Triangle. So we need the area of the triangle plus, and then I need to take this figure right here and cut it into some shapes that I know the names of. So I could choose to cut it right here, or I could choose to cut it right here. Either way, I can solve this problem because now I've turned it into shapes that I know the names of. I'm going to go ahead and cut it this way. What would we call this shape now? A rectangle. So the area of my triangle plus the area of a rectangle plus, and then we've got this guy right here. What would that be? A square. How do we know it's a square and not just something that's a rectangle that looks close to a square? The sides. We have 4 feet here, and then it tells me that this is 4 feet, so those two sides are congruent. All right, so area of a triangle, 1/2 base times height. Area of a rectangle, we do length times width. Area of a square, we take our side length and we square it. I think that's the easiest one for us to substitute into first. What is the side lengths of my square? 4. All the sides have a length of 4, so I would have 4 squared back here. The rectangle, what I have up here, I need length and width. Do I know either of those? Yes. How big's my length? 9. From here to here is 9. So there's my length. I can substitute that in. What about the width? How did you get that? You're absolutely correct. 6 subtracted by 4. We're told that the length of this entire side is 6, but from here to here is 4. So we do 6 feet minus 4 feet. So 2 feet for my width. So 9 times 2 for my rectangle there. All right, so that brings us back here to the triangle. I do know what my height is here. How big is that? 4, because it's the same size as this right here. So that is 4 feet. And now I need to find the base from here to here. 5. Tell me how you knew that. Yeah, 4 is right here. So from here to here is 4 feet. I know the entire length is 9 feet. So this would be 9 feet minus 4 feet. So I have 5 feet for my base. So 1/2 times 5 times 4. One half times 5 times 4 is how much? 10. So 10 plus 9 times 2, 18, plus 4 squared, 16. So 10 plus 18 plus 16 gives me 44. Do I need units with that? What should my units be? Feet squared, because we just found area. Nicely done. What'd you say? Oh, making this whole thing like into a rectangle and then subtracting those pieces out. You could absolutely do that. We have this. You would have to figure out this length right here, and then this side over here. You'd have like these 2 congruent holes there. To find this? Yeah. Mm-hmm. Yeah. And like I said, you can do it that way. I think as you saw, you kind of ran into a couple problems with doing it that way. If you try to do it with holes on a problem like this, and you're running into problems, maybe try adding them together. Whereas on a problem like part C over here, you have to do that one with subtraction. There's no way I could do this particular one with addition, because I'm going to have trouble finding the area of just one of these little like pieces between the chord and the edge of the circle. But subtraction is an absolutely valid way to go about just about any of these. Can I do part A in this section? Yeah. And then what would you like to see? Yes. Part A here on number 14. What 2 shapes have been put together to make the figure in part A? What 2 shapes have been put together to make the figure in part A? A rectangle and a trapezoid, yes. So we're going to do the area of the rectangle plus the area of the trapezoid. Area of a rectangle we just used, that's length times width. Area of a trapezoid, this is the one that's like the triangle, 1/2. We have 2 bases and 1 height. So height times base 1 plus base 2. For my rectangle, what's my length? What is the length of the rectangle? 24. Or we could have gone this way, that's fine. It doesn't matter which one you call the length and which one you call the width. But I'm going to go ahead and put in the one value that I know for sure, 24. And now I need from here to here. 11. How did you get 11? 15, subtracting this 4 right here. So 11 inches for my width. So 24 times 11 plus 1/2. What is the height of the trapezoid? 4. So 1/2 times 4 times base 1 plus base 2. How big are base 1 and base 2? 13 and 24. Here's base 1. This is base 2, and it's congruent to the bottom of that rectangle. All right, so the first thing I do is 24 times 11, which gives me 264. 1/2 times 4 times 13 plus 24 gives me how much? 1/2 times 4 times 13 plus 24. 74. So 264 plus 74 gives us a total area of 338 inches squared. What else would you guys like to see off the review? Part C? Yeah, absolutely. We can do part C here. For part C, I'm going to use some subtraction. We're going to do the area of the circle minus the area of the square. So the area of the circle, pi r squared, minus the area of the square, which is side squared. Do we know how big the radius of the circle is? So we got to hold off on that for just a minute. What about the side of the square? How big is the side of my square? 12. So I would have 12 squared. And they didn't have this in the picture, but how big is this side right here? Has to be 12. Since that's a square, all my sides are congruent. The next thing we need to find is the radius of the circle. I don't know how big that is. I don't even see it drawn in there. But if I draw in this diagonal for the square, that goes from edge to edge through the center on my circle. That is a diameter. This segment and this segment right here would be congruent, and those would both be radii of my circle. So if I can find the length of that diameter, then I can use that to find the length of the radius. What do we know about the corners on squares? It's a right angle. So that means that I have what shape right here? I have a right triangle. What can I use to find missing sides on right triangles? Pythagorean theorem. A squared plus b squared equals c squared. What should we put in for c? What is the hypotenuse of this shaded yellow triangle? D. Yes, my diameter. So I have d squared. So what goes in for a and b then? 12 and 12. 12 squared plus 12 squared. How much is 12 squared? So I have 144 plus 144 equals d squared. And 144 plus 144 is 288. I want to get the d all by itself, so I'm going to square root both sides. When I put this into my calculator, at least my yellow calculators, it's going to give me a radical answer back. But remember, I want to take this and cut it in half so that I can find the radius. So we're going to change it into its decimal form. What is the square root of 288 in its decimal form? 16.971 for our diameter. And so then our radius is half the diameter. So 16.971 cut in half. That comes out to be about 8.486. Thank you. So that is the value that we're going to put in for our radius right here. So I have pi times 8.486 squared. Pi times 8.486 squared comes out to be about 226.233. Minus 12 squared, which is 144. So when I subtract those two, I get approximately 82.233. They didn't give me units in the problem, so I would label this as units squared. Remember, the squared does not go on the number, it goes on the units. What other problems from the review packet would you guys like to see me work through? Number 12? Absolutely. Number 12, find the area of the triangle. I don't have the height in this triangle. The height would have to go from the farthest out point to one of the sides and make a right angle. So this could potentially be a height, or this could be a height, or this could be a height. The problem is I don't know how to find those because I don't know where it would be splitting that angle at. We do have another area formula for triangles though. We have 1/2 base times height. That's an older one. What was the new one that we learned in this model? 1/2 AB, and A there does not mean apothem and B does not mean base. A and B mean what here? Two of the sides of the triangle, yes. Times the sine of angle C, which has to be the angle in between those two sides. How many sides do we know on this triangle? We know two sides. We know this one over here, that's 18 feet. And we know this one over here, that's 26 feet. So I can go ahead and substitute those pieces in. Area equals 1/2 times 18 times 26 times the sine of angle C. And I can't just pick any old angle for this. I have to pick the angle that's in between the two sides that we just put into the formula. I don't know that angle. Do I have enough information to be able to figure out that angle? Because we know that all three angles in a triangle add up to how much? 180. So the measurement of angle X plus 74 degrees plus 44 degrees equals 180. So the measurement of angle X, not equals, plus 118 degrees equals 180. And then I'm going to subtract 118 from both sides. So how big is angle X? What is 180 minus 118? $62. So this angle right here is 62 degrees. That's what I have to put in for C, because that's the angle in between the two sides that we used in the formula. So from here I can grab my calculator and now I can type this whole thing in. 1/2 or 0.5 times 18 times 26 times the sine of 62 degrees. And I get approximately 206.61. And then what units would I need with that? Feet squared. Nicely done. What else would you guys like to see? Which one? 11, absolutely. For number 11, we need to identify several features from the picture. And for 4 of them, we need to find their measurements. So part A says we need to find the radii. A radius goes from the center to a corner. What is a segment in the picture that goes from a center to a corner? AG, the corner of the straight-sided shape, the polygon. So AG would be a radius. Do you see anything else that would count as a radius? BG goes from this vertex right here to the center. So BG, this segment here, would also be a radius. AG or BG. The apothem doesn't go from the center to a corner. It goes from the center to where on my straight-sided figure? The apothem does not go to a corner of my straight-sided figure. It goes from the center to where on the straight-sided figure? To a side, yes. What is the apothem in this picture? HG. Goes from the center of my polygon to one of the sides, and where it hits the side, it makes a right angle. So HG or GH. Minor arc. We're going to go in between 2 of the vertices here. So arc AB, or you could have arc BC, or arc CD, or DE. You want to go in between just 2 of the vertices. Remember, when we write an arc, you need that arch over the 2 letters. Minor arcs, we only need 2 letters. Major arcs, we need 3. To find the measurement of my minor arc, I'm going to do 360 degrees divided by how many chords are inside this circle here? 6 chords. 1, 2, 3, 4, 5, 6. My polygon has 6 shapes, or 6 sides, sorry. So we have 6 chords. 360 divided by 6 gives me 60 degrees for my minor arc. Major arc, now I'm going the other way. I don't want to go just between 2 adjacent vertices. I want to start at one of those and go the long way around the circle, like this. So AFB, or AEB, or ADB. You have to have 3 letters for a major arc. We want to start where my arc starts with one of those endpoints. So I started at A. We need 1 letter that's in the direction that we would travel, and then we need the endpoint of our arc. To find the measurement of that major arc, we're going to take 360 degrees all the way around the circle, minus the measurement of the minor arc, so minus 60 degrees. 360 minus 60 gives me 300 degrees. The central angle, there's only one central angle that they have pictured here for us. It's this one. You could name that AGB or BGA. So angle AGB. The central angle has the same measurement as the minor arc. You would do 360 degrees divided by the number of sides in our figure, which is 6 sides. So I get 60 degrees for my central angle. Your central angle and your minor arc should be the same size. An inscribed angle has to have its vertex on the circle. So this would be an example of an inscribed angle right here. So BAG. We want to find the measurement of that angle. So I am going to recopy this apothem right here, HG. And then we have our radius right here. And then we have half the side of the hexagon here. This is forming a right angle. We said that our central angle, this angle right here, was 60 degrees. What is the apothem doing to that angle, though? Splitting it in half. So how big would this angle be right here? 30 degrees. 60 cut in half would be 30 degrees. Here's A. This is the angle that we are wanting to find right here. I know the 3 angles in a triangle add up to 180. And I know 2 of the angles in this triangle. There's an 80-degree angle. Sorry, not 80, 90 degrees. I don't know why I said 80. We have a right angle, which is 90, plus our 30-degree angle. That was half of my central angle there. So I have 180 minus 90 plus 30 is 120. What is 180 minus 120? 60. Normally, my inscribed angle and my central angle are not the same size. That came out as a coincidence on this particular problem. The minor arc and the central angle would be the same, but typically the central angle and the inscribed angle are not the same. Yes?
I did my inscribed angle as
AEB. So you had to draw one in. If you did AEB, that's going to be half the measurement of this minor arc. So your inscribed angle, what you wrote, would have been 30 degrees.
Okay.
Yep. Yeah, you could do that if you drew in a completely different inscribed angle. Last piece to this problem. We need to write a congruence statement for the 2 congruent triangles that are pictured in the figure. So those 2 congruent triangles, here's one of them. And here's the other one. Let's go ahead and name the yellow triangle here, because the picture only shows those 2 triangles. What could we name the yellow triangle? HAG. Triangle HAG. That is congruent to my pink triangle. I have to be careful how I name the pink one now, though, because I have to make sure to match up the corresponding congruent parts. So angle H in the yellow triangle would be congruent to what in the pink triangle? H would not be the same size as B. H would be the same size as H.
Oh, I thought it was H.
Yep. This is a right angle here in my yellow triangle. Over in my pink triangle, that would be a right angle. So 90 to 90. What would be congruent to angle A in the pink triangle? There's B. So HB, and angle G in my yellow triangle would be congruent to what in my pink triangle? G. So HAG is congruent to HBG. We have 4 minutes left. That's enough time for a short problem. If anybody has one last one that they want to see that's a short one, yes. Number 4 is unfortunately a very long problem. 5, let's go look at 5. Number 4 looks short. Number 5 is reasonably short. The area of a rhombus. So we need to know our area formula for a rhombus. That is 1/2 diagonal 1 times diagonal 2. They tell us that the area of that is 342.5 square feet. So I'm going to put that in the place of A. Equals 1/2, and then diagonal 1 and diagonal 2. It says one diagonal is quadruple the length of the other diagonal. So one of my diagonals I'm going to call X, because I have no idea how big it is. The other one is quadruple, or 4 times that size, so we're going to call it 4x. So I would have x times 4x next to that 1/2. We're going to get rid of that fraction of 1/2 by multiplying both sides by 2. 342.5 times 2 gives me 685. Is equal to x times x gives me x squared, so this would be 4x squared. We divide both sides by 4. 685 divided by 4 is 171.25. That's equal to x squared. We take a square root of both sides. And that does not come out to be a very nice or pretty number. That's 13.086. So one of my diagonals is 13.086 feet. The other one is 4 times that, which is 52.344 feet. All right. Answer key is already up in Canvas. I will be posting videos for every single class period today, so if you had a question about one that I did not go over, like number 4, I know that will be on one of the other videos today. It is not in my first period video, so you can check 4th, 5th, or 7th period video if you want to see how to do number 4.